So we shall continue our phase 2 reactions in drug metabolism. Okay. So here in this phase 2, what is happening here? That is this polar drug having active functional group is being converted to non-polar inactive form. Okay. So that it can be eliminated. Okay. That is done here. Polar active functional grouped drug converted to non-polar inactive compound, and it is eliminated here. Okay, it is made more polar. Okay, polar drug having active functional group is converted to more polar drug having inactive groups. Okay, it is made inactive and it is made more polar, so that it is easy for elimination. Okay, here mostly the enzymes involved is transferase enzyme. Okay, it will be catalyzed by transferase enzyme, and again here 5 categories are there. Either any one of the thing it can follow. Okay, first it is forming glucuronide salts, or it can form sulfate, or it is reacting with amino acids, or it can be converted to methylated agents, or it can be converted to N-acetylated forms. Okay, so let us see one by one. First one is glucuronide uronic acid conjugation. Okay, here to donate this glucuronic acid, some compound is required that is present inside our body. Okay, so who is donating this particular glucuronic acid? Who is the cofactor here? Uridine diphosphate D-glucuronic acid. Okay, this particular molecule is donating its glucuronic acid moiety to the drug. Okay, so this is called cofactor, that is the donors. Okay, the donors of the conjugates. Who is donating the conjugate for the drug? That is cofactor. Okay, and the next one, who is carrying out the reaction? That is the enzyme uridine diphosphate glucuronide transferase. Okay, we have already seen transferase groups are involved here. Okay, so who are undergoing this reaction? That is either carboxylic acid or alcohol or phenol or hydroxylamine. Okay, these groups can be conjugated with this glucuronic acid, forming here you can see glucuronides. Okay, so that is happening here. So 3 things we have to recall for everything. So first one is cofactor, who is the donor of the conjugate, and which is the enzyme performing the reaction, and then who is undergoing this reaction. Okay, so here if you see this disadvantage, in our intestine beta glucuronidase enzyme is present, and this particular enzyme cleaves this particular glucuronides. Okay, and it is converting again to active form, and so it will be reabsorbed again. Okay, so once it is converted to glucuronide in our intestine, it is again converted to active form, and it is again reabsorbing. Okay, so it is not eliminated continuously. Okay, so complete elimination is a tedious one in this method. Okay, so next one is sulfate conjugation. Most of the drugs are eliminated using this conjugate. Okay, here you can see who is the donor, cofactor of this sulfate group. Who is the donor of this sulfate group? 3-phosphoadenosine 5-phosphosulfate. This particular compound is donating the sulfate conjugate. Okay, this is the cofactor. And who is helping this reaction? That is enzyme sulfotransferase. Okay, sulfate group conjugated, so sulfotransferase. Okay, so who is undergoing this reaction? It can occur with phenols or aromatic amines or N-hydroxy compounds or alcohols. Okay, any of these groups can undergo this sulfate conjugation. Okay, here you can see an example also. Here this is phenol. Okay, and it is being converted to sulfates. Okay, by the help of sulfotransferase. okay, and with the help of this 3-sulfo-adenosine 5-phosphosulfate, right? And here in this glucuronic acid conjugate, we forgot to see the example, that is salicylic acid here. Okay, I've already seen this carboxylic acid can undergo this conjugation. Here you can see. And this salicylic acid is adding with the donor, okay, and with the help of enzyme, it is being converted to glucuronide conjugates. Okay, so the next one, sulfates. So moving to the third one, amino acid conjugation, that is with amino acids. Okay, simple reaction. It is very simple. Okay, so these carboxylic acids group, okay, or aromatic hydroxylamine groups can also undergo this reaction. Okay, anyway, it should have an acid, carboxylic acid or amine group, so that it can be added with amino acid. Okay, so with the amino acid, it is giving amino acid conjugate, so that it can be removed out easily. So the fourth one is methylated conjugate. So here, who is the donor? That is, the cofactor is S-adenosyl methionine. And who is performing this reaction? That is the enzyme methyl transferase, methylated conjugate, so methyl transferase. Okay, methyl group is transferred. That's all, methyl transferase. So who is undergoing this reaction? Either hydroxyl or amino or thio groups can be undergoing this particular reaction. Okay, but the thing here to be noted is, this particular drug moiety that has to be eliminated is made more active through this methylated conjugate form. Okay, here you can see norepinephrine is being converted to epinephrine. We know this epinephrine is a neurotransmitter, which is very helpful, which is very active. Okay, so pharmacologically important final molecules is being obtained from the parent. So that is also happening here. It is not an inactive form. It is of course an active form. Okay. So here last one is N-acetylated conjugates. So who is the donor here? Cofactor is acetyl coenzyme A. This is donating N-acetyl group. Okay. And who is catalyzing this reaction? Of course, N-acetyl transferase. That's all. Okay. So here, what about the disadvantage? Here sometimes this drug is being converted to toxic compound. So it is creating side effects. So that is the problem here. So for example, here you can see this particular drug, isoniazid, and it is a drug used to treat tuberculosis. So after N-acetyl group conjugates, okay, so here it is forming an acetylated compound, and this is toxic to our liver. So hepatotoxicity is produced here. Okay, so toxic compounds are also produced through this conjugation reaction, side effects, right? And this is our sulfanilamide. Okay, so this is being converted to this acetyl conjugate and it is being expelled out, right? So to recall this phase 2, what is done here is this polar group or drug having active functional group is converted to more polar drug having inactive, or more polar inactive drug. Okay, that is being done here through the help of transferase enzymes. Okay, it will be transferring some conjugates to this drug, and this is done by 5 different reactions. So first one is glucuronic acid can be transferred to the drug with the help of this uridine diphosphate D-glucuronic acid, okay, by the enzyme uridine diphosphate glucuronide transferase. This will be transferring this glucuronic acid moiety from this compound to drug. Okay, and all these the drugs having either carboxylic acid or alcohol or phenol or hydroxylamine groups can be undergoing this particular conjugation reactions, and the main thing here is this complete elimination is hard for this type because this glucuronide is being cleaved off by this particular enzyme in our intestine and it is reabsorbing. Okay, so complete elimination is somewhat difficult. So sulfate conjugation, here who is the sulfate donor? Here you can see the cofactor 3-phosphoadenosine 5-phosphosulfate, and this particular enzyme, the sulfotransferase, is transferring the sulfate group from this particular cofactor to the drug. Okay, and what all the drugs can be conjugated here? Phenols or aromatic amines or N-hydroxy compounds or alcohols. Okay, here you have having phenol and it is being converted to sulfate conjugated compound. Okay, it is being converted to sulfate and it is removed out easily. And the third one is simple one. It is being conjugated with the amino acids in our body. Okay, so that amide linkage is created and it is made more polar and it is made water soluble, inactive, and it's eliminated out. And the next one is methylated conjugates. Who is donating the methyl group here? Here S-adenosyl methionine is transferring its methyl group to the drug, and this transfer is done by this enzyme methyl transferase. Okay, this will be transferring this methyl group from this particular cofactor to the drug. Okay, and the drugs having hydroxyl or amino or thio groups can undergo this particular reaction. And the thing to note here is this, through this conjugation reaction, the parent drug is made more active. Okay, so that is the problem here. Final product that is to be eliminated is pharmacologically more active. Bioactive compound is obtained. Okay, so last one is N-acetylated conjugate. That is, N-acetyl group is transferred to the drug with the help of N-acetyl transferase from acetyl coenzyme A. Okay, so final the disadvantage here, also one disadvantage is it is creating side effects. Okay, toxic compounds can also be created through this conjugation method. Okay, for example, this particular drug used to treat this tuberculosis, it is forming a hepatotoxic compound. Okay, that is the problem here. So for phase 2, it is the conversion of polar drug having active functional group to more polar inactive form, so that it can be expelled out easily. Thank you.